Okay, the first thing is to write the equations out and label them. Equation 1 and equation 2. So now, what is the elimination method? Elimination simply means that we are getting rid of a variable. We could decide to get rid of the variable x first, or get rid of the variable y first. If we're getting rid of the variable x, then that means we are finding the value for y. And if we are getting rid of the variable y, then we are finding the value for x. Okay, so that is what it means. So let's say we want to solve for x first, then that means we are going to eliminate y. So how do we do that? It is to make sure that the coefficient of y in both equations are the same. When the coefficients of y in both equations are the same, we can subtract, then subtracting, we get rid of y. Let's do just that. All right, so let's make the coefficient of y the same in both equations. What is the coefficient of y in equation 1? It is -4, or 4, so to speak. And what is the coefficient of y in the second equation? It is 1, or +1. So this is what we do. We are going to make sure that both coefficients of y in both equations are the same. We can simply multiply the y in the first equation by 1 and multiply the y in the second equation by 4. If we multiply -4y by 1, it gives us -4y. If we multiply y by 4, it gives us 4y. That way, you have a -4 and you have a 4. Okay, so you have 4 and 4, which means the coefficient of y are almost the same, or the same. Okay, so let's see how that goes. So what we are doing now is that we are multiply equation 1 by 1 and equation 2 by 4. So let's see how that goes now. This is what we mean by that. So 1 will multiply, 1 multiplies, 1 multiplies equation 1, and equation 1 is this. Okay, let me just type that. All right, 1 multiplies 7x minus 4y equals 23. So in the second equation, 4 multiplies 2x plus y equals 13. So let's see how that goes. So the next thing we have is this. Okay, 1 times 7x. Now, let's remember the reason why we are using 1 to multiply equation 1 and using 4 to multiply equation 2. When we multiply 1 by equation 1, then 1 times minus 4y will be minus 4y. When we multiply 4 by equation 2, then 4 times plus y will be plus 4y. So that way we are having 4y and 4y. Even though one is minus and one is plus, that does not matter. The sign will determine what we're doing later. So that is the reason, the exact reason. We want to make the coefficient of y in both equations having the same figure. So let's go. 1 times 7x gives us 7x. 1 times minus 4y gives us minus 4y equals 1 times 23 gives us 23. Now in the second equation, 4 times 2x gives us 8x. 4 times plus y gives us plus 4y. And 4 times 13 gives us 52. Now, this is what we have. We're going to call this equation 3 because the third equation, and we're going to call this equation 4 because it is the fourth equation. So now let's look at equation 3. The coefficient of y is minus 4, and equation 4, the coefficient of y is plus 4. Now how do we eliminate y? If we add up minus 4 and plus 4, minus 4 plus 4 should be equal to 0. Yes. So that means we have been able to get rid of y by simply adding both terms. So what we are going to be doing next is, since that works, what we are going to be doing next is we will be adding both equations. Add equations 3 and 4. So that's it. Let's go ahead with the addition. Now 7x plus 8x gives us 15x. Minus 4y plus 4y, as we've done here, gives us 0. So we don't need to write the 0. 0 is no value at all. Now for the constants, 23 plus 52 gives us 75. So 15x, then 75. When we get to this part of this stage in solving an equation, the next thing is to divide both sides by the coefficient of x, as we did earlier up here. So up here exactly, we're dividing both sides by the coefficient of x, which is 15. So we are doing the same thing right now. Divide both sides by the coefficient of x, which is 15. We have 15x over 15. Then on the right hand side, we have 75 over 15. So 15x over 15, of course, that gives us x. 75 over 15 is 5. So definitely our value for x is 5. Now that we've known our value for x, then the next thing is to use that new value of x in any of the first two equations. Those are equations 1 and 2. So let's see how that goes. Okay. Use the new value of x in, let's choose any equation, 1 or 2, right? Let's choose any equation. It could be 3 and 4 as well. It could be equation 1, equation 2, equation 3, or equation 4. But it's, let's just choose equation 2. Yes, because it's the simplest. It could be any one, and whichever equation we choose, we're going to get the same answer. So let's choose equation 2 only because it is the simplest there, so that we can arrive at an answer quite on time. All right, so in equation 2, we're using this new value of x, which is 5 in equation 2. So how does that go? What does that give us? So this is what we have. In equation 2, the equation is 2x plus y is equal to 13. Now that we are replacing x with 5, so we can conveniently say 2 times 5 plus y equals 13. 2 times 5 gives us 10 plus y equals 13. So we can collect like terms now. Only y will be left on the left-hand side, while on the right-hand side we have 13. The positive 10 is crossing over to the other side and becomes a negative 10. So y will be equal to 3. Therefore, we can say that x is equal to 5 and y is equal to 3. Now, this is the elimination method.